Okay, so we're back. And here we have our machine which takes a curve and which takes a set of characteristics for a masonry unit and lays one course of masonry. That's what we made in part one. And I'm just going to take this and group it. And now what we want to do is we want to extend from one course into a wall based on a surface. So the first thing I'm going to do is I'm going to take my my curve that I used from part one and just extrude it up into a surface. And then I'm going to grab a parameter to hold my surface. And now what I need is a series of lines from that surface. So we're going to take a series of sections. Let's just start with a point. We'll call this section origin. And I'm going to use that point to make a plane. And what I want to do is use that plane to cut a bunch of sections. So what I need is a series of planes. So let's get a series. The series is going to give us a bunch of numbers starting from 0. And then what we want is a brick height plus a mortar joint. Let's do what we did before. Let's call that a BM height. And what we actually want, first of all, is we want a line that gives us every other course, and you'll see why in a moment. And I'm going to do what I did before. Oops, let's get a function just of x, and let's say that's x times 2, and I'm just going to rename this component double. Again, this is really the only time I ever rename a component. So that is going to give me my step size for the series. And I'm going to start counting at 0. And I want one more parameter, which is going to be the number of courses. Start with 10. So this is giving me a series of numbers. I'm going to take a z vector. And what I can do now is I can move my xy plane here using that series of z vectors. You can see down here I get a series of planes. And if I go to intersect, there I can take a component that takes the intersection of a B-rep in a plane, otherwise known as a section. That is my, let's rename this, call it wall surf. And my section planes. And what that's going to give me is going to give me my lower course lines. So you see what I have over here, if you remember, is like a machine that takes a line and runs a course of brick along it. So let's just hook them up. And if and you'll see what we get is we get now a course of brick at each one of those lines. So now what we need is the intermediate courses. And because it's going to be common bond, we're doing these separately because we want to offset the bricks so that the center point of that intermediate course falls on the vertical joint. So what I'm going to do here is I'm going to copy this series and this move and this section and this component, this parameter, excuse me. But instead of starting counting at 0, I'm going to start counting at 1 joint up. And so you can see what that gives me is that gives me a second set of sections that's right here, the intermediate ones. So this is going to be my upper course lines. All right, let's turn off the preview on these guys. Okay, here's where it's going to get a little bit tricky. So if you remember from before, right here, these are the center points of my lower course bricks, right there. And what I want to do is I want to find the midpoint between these two. Here's a way of doing that. So this is, right, I have 10 courses. Each one has 22 bricks. You can see that there. So it's 10 lists of 22. I can do shift list, which by default shifts 1 to the left. And so then what I end up with is a list that starts from the second brick, right? But these are actually just the center points. And I can use the line component to draw a line from the left one to its right one. So then I'm getting the lines from this to this, this to this, etc. I'm going to dump it to a parameter, which I reparameterize. And then I can evaluate that curve. And I can evaluate that curve. Let's see, call this midpoint. Let's call it joint. And I'm going to set it to 0.5, because so I can evaluate that curve for its midpoint. You can see what I get. A little hard to see. And if I take that point, right, it's now in the middle of these two bricks, and I move it up 1 course. Right, so I want to transform that point with the z vector. And I want that z vector to be, where is it, 1 bm height. So I'll just copy that. This is clear. I want to bring it over. Now what I have is I have that point moved up. But what I really want to do, that point may not be on this line. It happens to be right now because you can see my wall is not moving in section. But if the wall starts to move in section, this point won't necessarily fall along that line in the course above. But what we can do is we can use curve closest point to say, what is the closest point to this sort of moved up point from below to our upper course line? And that point is going to be the center point. For our brick in the course above. So what we really need, though, beyond just the point, is we need the tangent of the curve at that moment. And unfortunately, we don't get that out of curve center point. So we need another evaluate curve, because we do get the parameter where that point occurs, so this little t. We hook that up. We hook this up. Now we got everything we need. And we can just kind of copy it off of this component right here. In other words, we're going to need a plane, and there we go. So if we bring that over here, right, then we can say, we can just hook up our point, right, that's that point, to be the origin of our plane. Our tangent vector, that's t, this is all stuff that I did in part 1 of the tutorial, to be x. And then t also to this cross product, by cross product it with z, then I get the perpendicular vector, which is y, and I get everything I need to create a new set of boxes, which are right there. Let me turn the surface off, and let me turn off the wall surface over here so you can see what we got. And what we got is what we have is common bond that that follows the curvature of this wall. Of course, this is only curving singly. It might be more fun if what we did was rebuild this surface. Before I do this, I'm going to turn off the update on Grasshopper. It can work a little faster. I'm going to rebuild. It's okay. And then turn the points on for the surface and grab some of the points in the middle here and move them. So now this is what I was talking about before. This wall is changing in section. If I allow it to update, what we should see now is we have a wall that's curving in plan and section that has been figured out as common bond. The other thing, by the way, that we can change is right now, because we're finding the center point of that line, where is it? The joint point was set to 0.5. The next brick is falling right on the vertical joint. If we were to change that to, I don't know, 0.33, now the joints are going to fall on the 1/3 point. It's all parametric. In the next tutorial, we're going to see if we can evaluate this brick coursing according to criteria that will ensure that, let's say, your bricks aren't cantilevering too far, and that your wall will stand up.